This is going to be the first video of Chapter 7, the reactions of alkynes. We're going to give you a brief introduction of how to do nomenclature of alkynes. So alkynes are basically any hydrocarbons contain a carbon-carbon triple bond. The name will be usually named as a YNE ending suffix. The true bond between two carbons are usually between two sp hydrogen carbon. Sp hydrogen carbon meaning the carbon has two sp hydrogen orbital and two unhybridized p orbitals. The true bond is composed of a sigma bond, which is a single bond, and two other pi bonds. So total 3 bonds. Now because of the linear geometry, the sp carbon usually would possess a 180 bond angle. The sigma bonds between two carbons are overlapping of sp hybridized orbitals. This overlapping is along the carbon-carbon nucleus axis, which possesses the most basic structure of any hydrocarbon. And then two unhybridized p orbitals, which are dumbbell shaped between two carbons, are overlapping along the side. So you would have this kind of overlap between two dumbbell shaped p orbitals as the second pi bond and the third pi bond. Because they both are bonds, so they're going to space out as much as they can, forming a 90 degrees between these two pi bonds. So you would have two vertical pi bonds. Now because it's a triple bond, therefore it's going to be stronger bonds than the sigma bond or double bond. And it's going to be shorter than the single sigma bond or double bonds too. Now, of course, the triple bond is an outstanding functional group of hydrocarbons, just like double bonds. Now, this is a general information for if you have functional groups, you tend to name the basic trains with the functional group at the lowest possible number of carbon. But if you have multiple functional groups, then how would you prioritize that? And here's the order of the priority between different functional groups. The carbon-oxygen bond, which is carbonyl group, has the highest priority. And then the hydroxy group, which usually indicates an alcohol. And nitrogen, which usually indicates an amine. And you can see most of the functional groups with the heteroatoms would have higher priority than the ones without heteroatoms, such as double bond or triple bonds, which are pure hydrocarbons. Now between double bond and triple bonds, there's really no significant distinction. In other words, they would tend to have the same priority. If any compound with a double bond includes a double bond and a double bond and a triple bond at the same time, you will give whichever have the lower number. Now, of course, in this chapter, we're going to focus on the triple bonds only, which is the alkynes. Now, here are a few examples of the name of alkynes. Let's see how we're going to come up with name or structure of this kind of thing. Now, top structure here, you can see there's a triple bond right here. Now, the longest the carbon chain that can include the triple bond would be this chain. Now, obviously, the other branch down here is shorter than the ethyl group above. Now, along this chain, the way we're going to number this is going to be from left to right in this case. Simply because the triple bond we won't start from an end that closer to the triple bond. Of course, in this case, this cyclopentane is going to be a substituent. So do not number this carbon as number 1, which is already part of the cyclopentane here. This entire cyclopentane is the substituent, same as this methyl group down here. So the basic chain of this alkyne is going to be numbered from 1, 2, 3, 4, 5, 6. And that's why it's called hexyne. One hexyne, meaning the triple bond is between number 1 and number 2 carbon. The lower number will be indicated in the name to show the location of the triple bond. Hexane, hexyne here basically is derivatized from a hexane. YNE, that's the signature suffix of a triple bond. Hex meaning there are 6 carbons. Now there are 2 substituents. On number 4 there's a methyl group. On number 1 there's a cyclopentane. So it will be named as 4-methyl-1-cyclopentane, or the other way of writing this will be 1-cyclopentane 4-methyl. The second comma here will be with a chloro and the triple bond. Now, any halogens, bromine, chlorine, or iodine, they're always going to be substituents. In other words, the chlorine here is actually not a function group. Again, halogens are not function groups. They can only be substituents. Now, the same thing, the basic chain is this one. We won't start with a carbon that's closer to the triple bond. So, therefore, we number the carbons from this end. 1, 2, 3, 4, 5. Now, one little detail worth to mention here is when you see the triple bond, such as here, here, or here, it looks like 3 dashed lines, but it's actually 1 carbon. And because all of these carbons are sp2 carbons, so you want to make sure this double bond, this single bond and triple bond angle is going to be 180 degrees. In other words, you would never expect the triple bond to be drawn this way. Now back to this example with 5 carbons and the triple bond between number 1 and number 2. And on number 5, there's substance of chloro. So it's called a 5-chloro-1-pentyne. Now there are also a few examples down here. Let's see how we're going to come up with names. So you might want to pause the video here to see if you can come up with names with these few examples. The first one to the left, we can see the triple bond and the longest strand might be this one. And the substituents, one of them is cyclohexane and the other one is methyl group. The rest of the basic base trend should be numbered from, in this case, where the triple bond starts. 1, that's a carbon. There's another carbon, 2, then 3, and 4, and 5, and 6. So the basic trend of this one is going to be 1 hexyne. The substituents are cyclohexyl and methyl. So the name will be, on number 1, there's a cyclohexyl. On number 4, there's a methyl. And then 1 hexyne. Next one. The longest carbon chain that includes the triple bond will be this one. Now, both nitrile group and the bromine groups are always going to be substituents. They are never going to be functional groups. Therefore, we need to number the basic chains starting from where the triple bond starts. So it's going to be 1, 2, 3, 4, 5, 6. So again, it's going to be 1 hexyne. On number 4, there's a nitro group. On number 5, there's a bromine group. So in the alphabet order, B is in front of N. So 5 bromo, 4 nitro, 1 hexyne. The last example here, which there's nothing else but just hydrocarbons. The longest strand that contains the triple bond is going to be this direction. Now there are two possibilities, obviously, with the other one goes down here. So you can see where when the strand splits, on one branch there are 3 carbons, on the other branch there are only 2 carbons. We would always go for the longest one, which is this direction. And when we number the carbons, we would number the carbon, the terminal carbon that's closer to the aux triple bond. So this is the end we're going to start. The other one is too far. So it's going to be 1, 2, 3, 4, 5, 6, and 7. And then on number 4, there's a substituent, 2 carbon substituent, which is ethyl group. So the basic strand of this is going to be heptyne. But the triple bond is between number 2 and number 3 carbon. So it's going to be 2 heptyne. And then on number 4, there's an ethyl group. So it's going to be 4 ethyl, 2 heptyne.